Hello everybody. I thought I'd make a quick video explaining quiz 7. There's some details I want to do in Desmos, and it's just easier if I can talk and point and you can pause and copy. So here's where we are. So for problem 2, that was basically a lump sum. Just let it go out 5 years and see what happens. So one option for plugging these things into Desmos is to name everything. So I've got everything with a subscript 2 just to indicate that it was from problem 2. So the initial amount from problem 2, the number of compoundings from problem 2, the time from problem 2, the interest rate from problem 2, etc. And then what I've done down here, so this problem said calculate the interest, not just the amount, but the interest. And so you see what I've done here is I've plugged in the formula. So 5 years, I've just used the names because I've defined everything up here. And then at the very end, I subtracted off my initial amount invested, and that will get me my interest. And there it is. That's what it is. Yeah, so that's your basic setup. I would suggest making this in Desmos once and then just changing these values. But you're free to do whatever you want, of course. Alrighty, so number 7 was a comparison problem. Number 7 says, if I deposit a lump sum at 9.25% and it's compounded semi-annually for 10 years, how much would I have to deposit for that to be the same amount as a lump sum at 10,000 deposited at 6.7% interest compounded daily, still after 10 years? So you see what I've done here is I've written X. Now you've got to do X if you want this to work, unfortunately. It's got to be X's and Y's. It can't be any other variable name. But this is the initial amount I don't know, right? So here's what I said was I want to know when this equals 0. So I plugged in initial unknown amount, 1 plus r over n, n times t there. And I've done the same thing for the second term, except we've got all known quantities. And then I just set it equal to 0. And if I turn this on, Desmos is going to plot the x value that solves that equation. And there it is, right there. Okay. I could even come down here and write x. Oh, no. It won't do that. Never mind. Never mind. But yeah, you can click on the value over here and you see that X is about 8,000. Okay. So number 14. So I'm using L for the loan amount there. And I've just plugged in the down payment right there. So cost of the car minus 2,000, get my L right away. I've done the same thing here. I've defined my number of compoundings, my T and my R based on the number of the problem there. And I'm going to calculate my monthly payment. So I have L, I have N and R, and I have T. So I'm ready to plug and chug. And, you know, just for safety, it's a good idea to multiply. When you have it defined as a number, you don't need to, but it's a good habit to get into with Desmos. So there we go. There's her monthly payments. It's as simple as that. And especially using Desmos, writing these formulas in like this, it becomes very, very simple. Okay, so number 17. So number 17, we were going to vary the times and the payments, but we weren't going to vary the number of compoundings or the interest rates. So I went ahead and defined those. And then I defined a variable P for Pauline as, well, the annuity formula for 40 years at $100 deposit. Then I used D for dad, so her dad has $400 deposited, 20 years instead of 40, but all the rest of the variables are the same, so I just plugged them in. What we see is that Pauline is doing better than her father. But maybe not as much as you'd think, but quite a bit. Now what I find interesting is Pauline only contributed 48 grand to her total of 189 grand in her retirement account. But she only contributed 48 grand. So this idea that saving early, even if it's a small amount, matters is something that we're trying to get across in this problem. For example, an old job of mine started an IRA for me. It would behoove me, and this is in the financial plans, as soon as I have enough spare income, I need to start putting back into that, because the sooner I put in, even if it's a small amount, it pays off in the long run. Pay more sooner when you're talking retirement accounts. That's the conclusion there. And you see, even though, yeah, they both got about $180 or $180,000 for their retirement account, basically twice as much of her dad's account actually came out of pocket. You see that? She's got slightly more, like $8,000 more, but she contributed almost half as much out of pocket. So that's kind of the benefit of saving early, saving often. Okay, so I'm going to save this, and I'm going to post it on As You Learn. And I'll see you guys in class in about an hour. Hope you have a wonderful day.